Hello everyone, welcome back to the Atharva Gate Academy. Myself Chinmay Thadu. Today in this video, we are going to start with elastic constant. What is elastic constant? It shows the relationship between stress and strain. Means it is a constant that shows the relationship between stress and strain. There are 4 elastic constants for homogeneous and isotropic material, that is E, G, K and mu. We have discussed E and G, right? Later on we will discuss all these 4 elastic constants. Now here there is small information that you can remember. Here there are different types of material, and here it is the number of independent elastic constant and it is the total number of elastic constant. For homogeneous and isotropic material there are total 4 elastic constant, and out of which 2 are independent. We know that for homogeneous and isotropic material, these 4 are the elastic constant, right? If we know value of any 2 elastic constant, then we can find out value of other 2 elastic constant by using that 2 value of elastic constant. Means we can say that here 2 elastic constant are independent. Likewise, for orthotropic material, there are total 12 elastic constant, and out of which 9 are independent. And for anisotropic material, total number of elastic constant are 36 and 21 are independent. Okay? Now we are going to discuss type of elastic constant. Here we are going to discuss 4 elastic constant E, G, mu and K. First is modulus of elasticity, or we can say Young's modulus, that is denoted by E. We have understood Hooke's law for tension and compression, right? By Hooke's law we can say that strain is proportional to strain, means sigma is proportional to epsilon. And here we put constant E, which is proportionality constant for this relationship. So it is sigma is equal to E into epsilon. And here this E is called as modulus of elasticity or Young's modulus, right? From here we can write that Young's modulus is equal to stress divided by strain. Now we know what is stress and what is strain. Stress sigma is equal to P divided by A, and epsilon is equal to delta L divided by L. If we write this deformation, means this change in length, as delta, then we can write that it is delta divided by L. Here this delta is change in length delta L. So here we can write that P divided by A, that is stress, divided by epsilon, that is delta by L. So we can write that Young's modulus E is equal to PL divided by A delta. Correct? Now what is the unit of Young's modulus? From here we can find out unit of Young's modulus. We know that unit of stress is generally taken as Newton per mm square, or it is in megapascal. And SI unit of stress is Newton per meter square, that is also called as Pascal. And we also know that strain is unitless. Unit of Young's modulus and unit of stress will be same. So this will be the unit of Young's modulus. Generally in the question, Young's modulus is given in megapascal or it is given in gigapascal. Means if we want to convert gigapascal into pascal, then we have to multiply with 10 raised to 9 power. So 1 gigapascal is equal to 10 raised to 9 pascal. And we know that 1 megapascal is equal to 10 raised to 6 pascal, right? So you should know that how to convert units. Now this second elastic constant is modulus of rigidity. It is also called as shear modulus, that is denoted by G. Now by Hooke's law of shear we know that shear stress is proportional to shear strain, means tau is proportional to gamma. If we want to convert this proportionally sign in equal sign, then we put proportionality constant, and here that proportionality constant is G. So it will be tau is equal to G into gamma. And here this G is called as modulus of rigidity or shear modulus. If we want to find out G, then we can write that tau divided by gamma, right? Now here what is the unit of G? We know that unit of tau means unit of shear stress is Newton per meter square or Newton per mm square or megapascal or pascal or gigapascal, right? These all are units of tau, means these are units of shear stress. We know that this shear strain is unitless, so these units are going to be units of G, means these are the units of modulus of rigidity or units of shear modulus. And generally value of G will be given in megapascal and gigapascal. And we also know that how to convert these units that we have discussed earlier, right? Now we are going to discuss bulk modulus, that is denoted by K. It describes the relationship between hydrostatic stress, that is actually normal stress, and volumetric strain. Now we have to understand what is hydrostatic stress. Let's say we have this cube like this, and we apply pressure on this cube from all the direction like this. Where we get this type of condition? If we put this cube in a water, then under water this cube experience this type of pressure. Let's say here value of pressure is P. And actually this cube is experiencing compressive stress on body, and it is same in all three directions, right? This type of stress is called as hydrostatic stress, and this situation of stress is also called as dilation. Here this P is value of pressure, and what is pressure? Pressure is force divided by area, so it will be same as stress in this body. So here this stress, which is hydrostatic stress, and it is actually normal stress because it is acting perpendicular to the cross section. So this stress is proportional to volumetric strain. And if we put proportionality constant here, then it will be K. So we can write that sigma is equal to K into epsilon V. Here what is epsilon V? Epsilon V is change in volume divided by initial volume, right? And what is this sigma? This sigma is nothing but the pressure P. From here K will be equal to sigma divided by epsilon V, and we can also write it as P divided by delta V divided by V, right? Let's say if value of pressure is given as 50 megapascal, then we have to take P is equal to minus 50 because it is actually compressive in nature, right? And if we are applying compressive load, then volume is going to be decreased. So we have to take volume change, means delta V, as negative value. So here this minus sign will be cancelled out, and we will get value of K as positive. So you have to understand that always value of bulk modulus is positive. Okay. Now here what will be the unit of K? We know the unit of stress, right? It is same as discussed earlier. And here what is unit of epsilon V? We know that epsilon V means volumetric strain is unitless, right? So here the unit of K means unit of bulk modulus will be same as unit of stress. So unit of K also will be Newton per meter square or Newton per mm square or megapascal, or we can say gigapascal. Now we are going to understand Poisson's ratio, that is denoted by mu. It is the ratio of lateral strain to linear strain. Here lateral strain is also called as transverse strain, and linear strain is also called as longitudinal strain. So we can also say that Poisson's ratio is the ratio of transverse strain to the longitudinal strain, right? And now let's say we have this body which is fixed at the left hand side. Here this is the length of body L, this is the height of body H, and this is the width of body B. Here we are going to apply tensile load P on the body in right direction. So here this direction will be taken as longitudinal direction, or it is also called as linear direction because it is the direction along force. And here other dimension, that is vertical and direction along width of this body, will be taken as transverse direction, right? Or we can also say that direction along width of the body and direction along height of the body is lateral direction. Here this length will be linear dimension and width and height will be lateral dimension, right? That we have discussed earlier. Now what is mu? Mu is the ratio of lateral strain divided by linear strain. Now what is lateral strain here? Strain along lateral direction of body is taken as lateral strain, right? So here what will be lateral strain? Lateral strain, let's say epsilon L will be change in width, that is delta B divided by B, right? And it will be equal to delta H divided by H. Here this delta B and delta H is change in lateral dimension, and this B and H is original lateral dimension. So what is lateral strain? Lateral strain is change in lateral dimension divided by original lateral dimension, right? And here this both will be same because our material is homogeneous and isotropic material. Now what will be linear strain here? Linear strain, let's say epsilon, it will be change in linear dimension, that is delta L divided by original linear dimension, that is L. Now what is the value of mu? Mu is ratio of lateral strain divided by linear strain. So it is epsilon L divided by epsilon, right? Here there is a reason to take negative sign. If we apply tensile load in linear direction, then this length will increase. So delta L will be positive. And so this epsilon means linear strain will be positive, right? And if here length of the body is going to be increased, then width and height of the body will decrease, right? So here this delta B and delta H will be negative. So finally this epsilon L, that is lateral strain, will be negative, right? So here this ratio will be ratio of negative value to the positive value. So finally this ratio will be negative, and we take value of mu as a positive value. So to make this ratio as positive ratio, we take negative sign here. So this ratio will be positive, right? So finally Poisson ratio will be positive value. So understand that to take value of Poisson ratio as a positive value, we take here negative sign. Now what will be the unit of mu? Here there is lateral strain and here there is linear strain, and we know that strain is unitless, right? So Poisson's ratio also will be unitless. Now here there is value of mu for different types of material. It is not important because value of mu will be given to you. For cork, cork is a material for which value of mu is 0. Means for cork value of Poisson's ratio is 0. Means there will not be any deformation in lateral direction of body. Now for concrete, value of Poisson's ratio is between 0.1 and 0.2. For metal, Poisson's ratio is between 0.25 and 0.33. For rubber, clay and wax, value of Poisson's ratio is 0.5. Now next is relationship between the elastic constant E, G, K and mu. Here this equation shows the relationship between these four elastic constants. It is very important formula because many times question asked from this equation, right? So must remember this equation. It is simple to remember. E is equal to 2g 1 plus mu is equal to 3k 1 minus 2 mu is equal to 9kg divided by 3k plus g. If you know any two values of elastic constant, then you can find out another two value of elastic constant from this equation, right? If g and mu is given, then you can find out E. If k and mu is given, then you can find out E. And if k and g is given, then you can also find out E. And similarly, if you know E and g, then you can find out mu, and likewise. And also remember this relationship. For any metal, G is less than K is less than or equal to E, means value of modulus of rigidity is less than value of bulk modulus is less than or equal to value of modulus of elasticity. Here there is only less than and here there is less than or equal to. So from here you have to remember this relationship and this very important equation. Now we are going to discuss volumetric strain for triaxial load. In the figure you can see that we have one cuboid and in that this dimension is length L, this dimension is width B and this dimension is height H. Here we take this direction as X direction, this direction as Y direction and this direction as Z direction. And we apply three different load on three surface of body. And we apply axial loads on this body. Axial load Px in the X direction, axial load Py in Y direction and axial load Pz in Z direction. Here there are also three loads which are equal in magnitude and opposite in direction at the opposite surface of this cuboid. So this body will be in equilibrium. Fine. Here we apply three different load in three direction X, Y and Z. So this condition is called as triaxial loading condition. And in this condition we are going to find volumetric strain epsilon V. First of all, we are going to find value of stress in all three directions of this cuboid. What will be the value of sigma x, means normal stress in x direction? It will be load in x direction, that is Px, divided by area which is perpendicular to this load Px. So it will be this area, right? And what will be the value of this area? It will be width B into height h. So divided by B into h. Here this sigma x is value of stress due to axial load Px. Now what is the value of stress sigma y in y direction due to this load Py? It will be load Py divided by cross section area, that is this area. It will be this length L into width B, right? So it will be L into B. And what will be the value of stress in Z direction due to this load Pz? It will be sigma z is equal to Pz divided by area which is perpendicular to this load, which is this length L into height h. L into h. So these are the value of stress in x direction, stress in y direction and stress in z direction due to load Px, Py and Pz respectively. Fine. Now we know that value of epsilon V is delta V by V and it is equal to epsilon x plus epsilon y plus epsilon z, means volumetric strain is sum of strain in x direction, y direction and z direction. So first of all we have to find out value of epsilon x, epsilon y and epsilon z. To find these values we are going to make one table in which we will take strain here and here we will take stress. Here we have three stress sigma x, sigma y and sigma z. sigma x, sigma y and sigma z. And we have three directions x, y and z. Here we are going to put value of strain. Here we will put value of strain in x, y and z direction due to stress sigma x, sigma y and sigma z. First of all, we are going to put value of strain in x direction due to stress sigma x. At that time, we are going to neglect sigma y and sigma z. For that, we are going to neglect these two loads. Means it will be a case of axial load Px on this body. And we know the equation sigma is equal to Young modulus into epsilon, that is strain. So from here we can find out strain epsilon. It will be sigma divided by E. Right? And here what will be the value of strain in x direction? Strain in x direction epsilon x will be sigma x, that is stress in x direction, divided by Young modulus E. Right? So this is the value of strain in x direction due to axial load Px. So here it will be sigma x divided by E. Right? Now we know the another equation of mu, that is Poisson ratio. It is lateral strain divided by linear strain. Right? In this case, linear strain will be in x direction and lateral strain will be in y direction and z direction. So from here we can write that mu is equal to minus epsilon y divided by epsilon x, and it is equal to minus epsilon z divided by epsilon x. It is minus lateral strain divided by linear strain. Right? Here we know the value of epsilon x. Epsilon x is sigma x divided by E. So from here we can find out epsilon y and epsilon z. Right? So here what will be the value of epsilon y? Epsilon y means strain in y direction due to stress sigma x will be minus mu into epsilon x. Right? And what is the value of epsilon x? Epsilon x is sigma x divided by E. So it will be minus mu sigma x divided by E. So we are going to write this strain here. And similarly from here what will be the value of strain in z direction epsilon z? It will be minus mu into epsilon x. So it will be same as epsilon y. Right? So strain in z direction due to stress sigma x also will be minus mu sigma x divided by. I hope that it is clear to you how to find value of strain in x, y and z direction due to axial load Px applied on the body. Now we are going to find value of strain in x, y and z direction due to stress sigma y. So at this time we are going to neglect these two load and we will only consider this Py load applied in y direction. So this is the case of axial load. Now in this case, what is the value of strain in y direction? We know that sigma is equal to E into epsilon. So from here epsilon y will be sigma y, that is stress in y direction, divided by E. So it will be strain in y direction due to load Py, or we can say due to stress sigma y. Now again, what is the value of mu? Poisson ratio mu will be lateral strain divided by linear strain. Now at this time linear strain will be in y direction and lateral strain will be in x direction and in z direction. So mu will be ratio of minus strain in x direction divided by strain in y direction. It is lateral strain and it is linear strain, is equal to minus epsilon z divided by epsilon y. Here this epsilon z is lateral strain and this epsilon y is linear strain. Right? From here what will be the value of epsilon x? Epsilon x will be minus mu into epsilon y. And here we are going to put value of epsilon y from here. So it will be minus mu sigma y divided by E. So this is going to be the value of strain in x direction due to stress sigma y in y direction. So it will be minus mu sigma y divided by E. And similarly from here, what will be the value of strain in z direction? Strain in z direction will be minus mu epsilon y, right? And what is the value of epsilon y? Epsilon y is sigma y divided by E. So it will be minus mu sigma y divided by E. So strain in z direction due to stress sigma y will be minus mu sigma y divided by E. Likewise, if you will follow same method to find out value of strain in x, y and z direction due to stress sigma z, then it will be minus mu sigma z divided by E. Here it will be minus mu sigma z divided by E, and here it will be sigma z divided by E, right? So in this table we have all the value of strain in x, y and z direction due to individual load Px, Py and Pz. Now to find out value of strain in x direction, that is epsilon x, due to triaxial load applied on this body, we have to take sum of all the strains in x direction due to sigma x, sigma y and sigma z. In short, to find out value of epsilon x, we have to take sum of these three strains. So it will be sigma x divided by E minus this term mu sigma y divided by E minus this term mu sigma z divided by E, right? And what is the value of strain in x direction? It is dl by L, and here this dl is change in length, right? Similarly, what will be the value of strain in y direction? It will be dh divided by h, means change in height divided by initial height. And to find out epsilon y, we have to take sum of all these three terms. So it will be sigma y divided by E, here I write this term first, minus mu sigma z divided by E, that is this strain, and minus mu sigma x divided by E, that is this strain. And similarly, value of epsilon z will be change in width divided by width is equal to sum of all the three strain in z direction. So it is sum of these three strain. So here it is sigma z divided by E, that is this term, minus mu sigma x divided by E, that is this term, minus mu sigma y divided by E, that is this term. So from here you have to remember all these three equations. Now finally our intention is to find out volumetric strain. That is epsilon V is equal to delta V divided by V, that is epsilon x plus epsilon y plus epsilon z, right? And here we have value of epsilon x, epsilon y and epsilon z. So now we have to add all these strains. So from here if you will find epsilon V, then we have to add all these 9 terms, right? So if you will add these 9 terms and simplify, then you will get epsilon V is equal to sigma x plus sigma y plus sigma z divided by E into 1 minus 2 mu. So from here you also have to remember this equation. These all equations are important because many times question have been asked from this equation. So must remember all this equation, okay? We have derived this equation, that is equation of volumetric strain for triaxial load. Epsilon V is equal to dV by V, that is equal to epsilon x plus epsilon y plus epsilon z is equal to sigma x plus sigma y plus sigma z divided by E into 1 minus 2 mu. Here this equation is for triaxial load. Means there are 3 load applied in 3 different directions. If we want to find out value of volumetric strain for biaxial load, then let's say we remove this PZ load. So this loading condition is called as biaxial loading condition, because here we apply load in 2 directions, x and y. So in this case, value of volumetric strain will be epsilon V is equal to sigma x plus sigma y divided by E into bracket 1 minus 2 mu. Here we put sigma z is equal to 0, right? Because in this case, stress in z direction will be 0. Now if we want to find out value of volumetric strain for uniaxial loading, then let's say here we are going to remove this load Py. So this is going to be the case of uniaxial loading condition. So in this case, value of volumetric strain will be sigma x divided by E into bracket 1 minus 2 mu. Because here we put sigma y is equal to 0. Because there is no any load in y direction, so stress in y direction will be 0. So from the equation of triaxial loading condition, we can derive this equation of volumetric strain for biaxial and for uniaxial. So you also have to remember these two equations. Actually you don't have to remember, because you can put value of stress 0 in this equation, right? So you only have to remember this equation. I hope that you understand how we find this value of strain. After watching this video, try to remember the equation that we have discussed in this video, because equations are very important to solve question in the GATE, right? Today we are going to stop here and we will continue in the next video. Till then, stay motivated and happy practicing.